Okay, so in this video, we're going to learn to convert grams to moles and moles to grams. This is really important in doing future calculations in chemistry class. All right, so calculate the number of moles of carbon in a 0.58 gram diamond. All right, what you're given is 0.58 grams of carbon, and it asks you to find the moles of carbon. Okay, so we're going to go from grams to moles. Now, we just learned that on the periodic table, the masses that are given for each element are the molar masses. So if you look at the periodic table, you'll see that the molar mass of carbon is 12.01 grams per 1 mole. Okay? So we're going to use this as a conversion factor to get from grams of carbon into moles of carbon. All right. So start with what we're given, 0.58 grams of carbon, and we're going to use that molar mass. I know that 1 mole of carbon has 12.01 grams, so my grams are going to cancel because I have grams on the bottom. And if you calculate this out and put it in your calculator, you're going to end up with 4.8 times 10 to the negative 2 moles of carbon. Okay, so these kinds of calculations, gram to mole calculation and mole to gram calculation, have to happen in many chemistry problems. So we want to have a lot of practice on these, so make sure that you're practicing a lot on your own. All right, so here's what we did. We started with our grams of carbon, and we used the molar mass of carbon to get into moles of carbon, and then from there you can get into atoms of carbon if you were to multiply that by Avogadro's number. Okay. All right. So just like when we were starting with our pounds of nails, we used 1 dozen nails is 0.150 pounds of nails. Okay, that got us into dozens of nails. And then we could figure out the number of nails by knowing that 1 dozen has 12 nails in it. All right, so we're going to try this next problem. And it says, how many aluminum atoms are in an aluminum can with a mass of 12.2 grams? All right, so I can tell that we have 12.2 grams. That's starting with what we're given. If we use the molar mass of aluminum, we can convert from grams of aluminum into moles of aluminum. And then once we're in moles of aluminum, we can determine how many atoms are in aluminum using Avogadro's number. All right, let's get started. So we're given 16.2 grams of aluminum, and we need to find aluminum atoms. All right. In the first step, we're going to convert our grams of aluminum to moles of aluminum. In the second step, we're going to convert our moles of aluminum to the number of atoms of aluminum. Okay, so we need to use the molar mass of aluminum for the first step, and then we need to use Avogadro's number for the second step. Okay. All right. And here is your little solution map, starting with what you're given. These are your conversion factors that you're going to use. This is your molar mass of aluminum, and this is your Avogadro's number. All right, let's get started. All right, so starting with what we're given, we have 16.2 grams of aluminum. Now I'm using the molar mass. I'm just going to say molar mass here. Oops, mass of aluminum. Okay, doing that, I'm able to get into moles of aluminum. But the question doesn't ask me how many moles of aluminum, it asks me how many atoms of aluminum. Well, I know to get from moles of something into atoms of something that I can use Avogadro's number. Okay, so now that I'm in moles of aluminum, I need to have moles on the bottom here, and I need to have atoms of aluminum on the top here. And so all my units cancel except atoms of aluminum. That's what I'm left with. And we can calculate this out. 16.2 divided by 26.98 multiplied by 6.022 times 10 to the 23rd atoms. And to the correct amount of significant figures, you end up with 3.62 times 10 to the 23rd atoms. All right, is your unit correct? Does the answer make sense? All right, the unit, aluminum atoms, are correct. The answer makes sense because the number of atoms in any microscopic sized sample is going to be very large. Okay. All right, let's try this one. Calculate the mass of 1.23 times 10 to the 24 helium atoms. All right, I did a little bit of pre-work here, and I went ahead and I got the molar mass of helium for this next problem from a periodic table. All right, so this one says calculate the mass of 1.23 times 10 to the 24th helium atoms. Okay, so this one starts us in atoms, and it wants us to go, so atoms, and it wants us to get to grams. Well, I know that I first have to go from atoms, and I have to go to moles, and then using the molar mass, then I can get to grams. Okay, sometimes this pen doesn't work well, but this word here is atoms. All right, so I'm going to start with what we're given, and I had to use just a little bit of the screen because we're going to have something pop up on the left here, so I may have to spread it out into two lines. So I have 1.23 times 10 to the 24th helium atoms, and I want to get from atoms into moles. Okay, so I have to multiply or divide by Avogadro's number to get from atoms to moles. I know that 1 mole of helium has 6.022 times 10 to the 23rd atoms. Okay, kind of cramming this in here. All right, and now my atoms cancel, and now I'm in moles of helium, but I don't want moles of helium. The problem specifically asks for mass. So how do you always get from grams to moles or moles to grams? You're going to use the molar mass. Okay, so I have here, I have moles on top, so I need to have moles on bottom. I know that 1 mole of helium has a mass of 4.003 grams. Fell off the page there. There we go. So my moles of helium cancel, and I end up in grams of helium. All right, so now I have all of my units canceling, and I ended up in grams of helium. So now I just multiply across. All right, so when I put that in my calculator, and I actually did this 3 times, first time it came out a really weird number. I always enter them in twice and make sure I can get the correct number, but I took 1.23 times 10 to the 24th, divide by 6.022 times 10 to the 23rd, and then multiplied by 4.003. And when I put that in my calculator to the correct amount of significant figures, I get 8.18 grams of helium. All right. Excellent. So here are some more problems that you guys can try that are in your book. Practice really helps. So just always remember, when you want to get from grams to moles or moles to grams, you're going to use molar mass. Okay? Perfect. All right, so far we have been talking about just converting from grams to moles and moles to grams of an element on its own. But what if we were talking about the molar mass of a compound? All right, the molar mass of a compound in grams per mole is numerically equal to the formula mass of the compound in atomic mass units. The formula mass for a compound is the sum of all of the atomic masses of all of the atoms in the chemical formula. So basically, you guys, for NaCl, you would look at the periodic table and see what is the molar mass of sodium and what is the molar mass of chlorine if you were wanting to determine the molar mass of NaCl. All right, so let's just try one for an entire compound rather than just an element so we can get going. Calculate the mass in grams of 1.75 moles of water. So notice this time we're talking about a compound, H2O. We're not just talking about oxygen. Okay. You are given moles of water and asked to find mass. Okay. So in order to convert from moles to grams, I need to have the molar mass of 2 hydrogens and an oxygen, okay? They've already added it for you here, but if you guys were to look at your periodic table, to get the molar mass of water, you guys are going to get on the periodic table, the atomic mass of 2 hydrogens and the atomic mass of 1 oxygen. That equals 18.02 grams per mole. All right, now that I have the molar mass of water, isn't it easy to get out of moles of water and into grams of water? It is, because I know that 1 mole of water has 18.02 grams. All right, let's look at the next slide. So I start with the 1.75 moles of water. I'm going to use the molar mass of water. That's just the masses of 2 hydrogens and an oxygen added up together. And you calculate that out, and you get 31.5 grams of water. All right, yes, this does make sense. All right, let's try this one here. All right, here's one to try. Calculate the number of moles of nitrogen dioxide in 1.18 grams of nitrogen dioxide. All right, so if we want to know the number of moles in this many grams, we have to have the molar mass of nitrogen dioxide. If you look at the periodic table, you'll see that nitrogen has a mass of 14.01. Oxygen has a mass of 16.00. Since there are 2 oxygens, I have to multiply that by 2. So I have 14.01 plus 2 times 16, which equals 46.01. One minus that away. All right. So now I'm going to start with what I'm given, 1.18 grams of nitrogen, and I need to, here we go, multiply this by the molar mass. So I know that 1 mole of NO2 has a mass of 46.01 grams. And my grams are going to cancel. I'm going to end up in moles, and let's see with. All right, so when I calculate this out, I'm taking 1.18 divided by 46.1, which is the molar mass of nitrogen dioxide. And when I put that in my calculator, to the correct amount of significant figures, I end up with 2.56. Oops, I don't know. There we go. Sorry about that. 6. Let me pause for a second. All right, 2.56. Sometimes this pen just really acts up. All right, times 10 to the negative 2 moles of NO2. Okay, so we started in grams, which is what we were given. We used the molar mass, and so divide by 46.01, we end up with 2.56 times 10 to the negative 2 moles of nitrogen dioxide. All right, here are some practice problems for you. We'll do more in the next video. Good job, guys.